Okie dokie. Right, if you can write that down, that's what we'll have a look at first today. Do you want me to spray you with some water to cool you down? Okay.
Oh. This is plain water.
I think it's actually
It's broken. No water for you, so. Now, you got that? Resolving vectors? So, a couple of things to look at today. Right. We know these words horizontal and vertical, don't we? Or we don't? Which is horizontal and which is vertical? That's horizontal, yeah, and that's vertical, yeah. These vectors can be added together, just like any two vectors. And this is a very common problem in mechanics. Likewise, so is the reverse. That is, taking a vector and writing it as its sum. So I'll just draw what I'm talking about here. Oops. Suppose we have horizontal vector plus a vertical vector. That will equal, what colour have I not used? I've used them all, have I? Let's go back to black. So black equals that. Okay. We know how to do this. What do we do to do this? Or how do we do this? We use the vector triangle. Remember that? Where you put the red one here and the blue one here, and you have the what letter is this? If this is A and this is B and this one here is called OR. Okay. What we would like to do today is we would like to start with OR and change it into a horizontal plus a vertical. Yes, yeah. We'll just use sine and cos though, yeah. This is called resolve the OR vector, is when you go backwards. And this one here is where you calculate the resultant, or get the resultant. Calculate the OR, and then resolve the OR. So you might want to write those words down. That's important to know the difference. Okay, you got that? Yeah? Yeah? Okay. Now, we have some tools to help us. We all know this formula. You learn it when you're very little. Pythagoras theorem. I don't even think you have to write this down. You should all know this, right? But maybe you don't know the name. Maybe it's different in your home country. Do you all know the name Pythagoras? Yeah? I know it's a bit different in Chinese, isn't it? What's it in Chinese?
Go.
Yeah, that's what I remember someone saying, go-go or something. But in Arabic it's the same, isn't it? I don't know, any Arabic speakers? No?
In China, we usually study the cosine theorems, the development of this.
Yeah, we do cosine as well, yeah. Well, we do it in maths class. So anyways, you all know Pythagoras, I hope. So here, I mean, so simple. Let's take 2 seconds. 3 meters east, 4 meters north. How do you get the magnitude, the hypotenuse? The magnitude is 5 from Pythagoras. Easy peasy, even little children can do it. If this is 3 and this is 4 and this is x, you say x squared equals 3 squared plus 4 squared. So x squared is 25 and x is 5. Yeah. For babies, right? Now, maybe some new words for you. The sides of the triangles have names. If this is the angle here, we call this side the opposite, we call this side the adjacent, and we call this side the hypotenuse. Now, I don't know if you know these words. Some of you might. But I would think it's a good idea to write it down. Oh, no pictures. No. Right. Right. Got that? Yeah? Did you know these words? Yeah, some of you did, yeah. You're not sure, okay. Well, you know them now. Does anybody know this word? Sokotoa.
Yeah.
You know it?
That's how we learned it.
That's how you learned it, yeah? Does anyone know this word else? You know Sokotoa? What's Sokotoa? Yeah, that's it, yeah. You were saying about arctan earlier. So yeah, we can use arctan to get the angle here on the calculator. We can say, if you have a vector here, and you want to know this angle, and you know this length, let's just call it, what letter we say, we'll keep it A, and you know this one here, this is O, then you know that theta is equal to tan inverse O over A. Now you should have this button on your calculator. Yeah. And this is how we can calculate the angle. So let's go back to our example we did a moment ago, where this is 3 and this is 4 meters, and I want this angle. Can you take out your calculator and make sure you can get the answer? It should be tan inverse 4 over 3.
Yes, I was wondering why I couldn't get it right. And apparently my calculator was set in radians.
Radians would be the problem, yes. We'll actually do radians in a few weeks.
Okay.
What's the angle here?
53.1.
Yep. Okay. That's fine, isn't it? Yeah, we're happy with that? Yes?
A small question. Why is the 4 size is longer than 3?
Because I'm bad at drawing pictures. That's why. Okay. I'm a physics teacher, not an artist. That's the reason. Okay, so we have these formulas to calculate sides and angles. Formulas you would have seen before. Some people have remembered the word Sokotoa. It means sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Here it is in the formulas. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. I think it'd be good to write these down.
We can exercise several times in Chinese.
Hundreds of thousands of times, probably.
Yes, and we not only exercise the cos, we exercise the square B, square C, and the 2BC cos A. That's
I know. I hope this is not difficult. That's a good thing. Yeah. Right, you got that? Yeah? Yeah. Often we know the magnitude of the hypotenuse and the angle. And basically you want to know the magnitude of the opposite and the adjacent. So I'll explain with a picture now. I'll just switch to my writing pad for a sec here. So this is normally the situation we have. Normally we have a vector, okay, and we know this length and we know this angle. And we would like to know this length, and we would like to know this length. So often we are given r and theta, and we want x and y. Okay. Now we can use the rule that sine theta, what will that equal? Y over r. Yes? And cos theta equals x over r. Therefore, x equals r cos theta and y equals r sine theta. Okay? So if you know r and theta, you can quickly get the two sides. This side here would be r cos theta, and this side here would be r sine theta. Yeah, so just I'll do a quick example. Suppose I give you this. We'll say this side is 2 and this side is 20. Then this length here will be 2 cos 20. What's that, please? 2 cos 20.
1.88.
Say again?
1.88.
1.88. And then this side here is 2 sine 20.
0.68.
0.68. See? Quick to do. I like to remember that the theta is always on the side with the cos, and the theta is always opposite the side with the sine. That's how I remember it. So like if I drew a crazy picture like this, and here's theta, and this is r. Which is this? Cos or sine? Yeah, this is r cos, because it's the side that touches the theta. And this one here is sine, because it's the side opposite theta. Okay? Right. You should write that. So this is a useful calculation. Important calculation. Yeah. Okay, continue. Yeah? Yeah? So, speed, another way to think about it is the magnitude of the velocity vector. So, for example, if I tell you, oh, here's a little boat, and maybe it's heading this way, it's going in this direction, so off it goes. It's my boat. I told you I'm not an artist. Let's move along there. And let's say its velocity is 5 east and 12 north. What's this length here? Or what's this side here? 13. So you could say that the boat has a speed of 13 meters per second, which it does because it's heading this way at 13. Or you could say it has a velocity of 5 meters per second east, 12 meters per second north. Or you could say it has a velocity of 13 meters per second at an angle east. What's this angle here, please?
36.9.
Is it this one, the 36 one?
I think so.
Yeah, tan inverse 12 over 5. I thought it was 51 or something. Tan inverse 12 over 5? What's that?
67.
67.4 degrees north. These all are saying the same thing. Here the speed of the boat is 13. Here the velocity is 5 east, 12 north. Or you could say the velocity is 13 at 67.4. They're all describing the same boat. Okay, we can think of speed as the magnitude, as like this length, this side. Yeah. Some of you look unhappy. What are you unhappy about? These two are the same. No? Oh, you look very unhappy. What's wrong? No? Yes?
Where's the boat? How's the boat moving?
It is moving this way.
That way.
Yeah. It actually is moving diagonally. Yeah. It's not doing this. It is going this way. Continue? Yeah? Okay. Okay. I'll let you try this one for a minute. You need the calculator. You have 10 horizontal and 20 vertical. I want the magnitude and direction. Direction meaning the angle. So I'll draw it here for you. It's 10 this way and 20 this way, meters per second. Okay. Okie dokie, we got answers? No? I want to know this and this. Right, so what's the magnitude? 23.4 meters per second. Sorry, what is it? 22.4? 22.4 meters per second at east. And did we get an angle here? 63.4. Yeah? Okay. North. Yeah? It's okay. So the way we got this is square root 10 squared plus 20 squared, and the way we got this was tan inverse 20 over 10. Yeah, we call this tan inverse, not arctan here. Americans call it arctan. Okay, continue.
We should use red or degrees when we're using the octane.
Degrees for the moment. A ship is sailing 15 kilometers per hour at a bearing of 30 degrees. How fast is it traveling to the east and to the north? So what you have is a ship at bearing 30. Do you remember which way is bearing? From the north. So the ship is going this way at an angle of 30 degrees, and its speed is 15 kilometers. I need to practice just writing H, not HR, per hour. And then I want to know what is the east part here, and I want to know what is the north part here. That's what I'm looking for. Okay, try that. Right, the east part should be 15 cos 60. Or you could type in 15 sine 30. You should get the same answer. Because this angle here is 60. Right? Yeah. And this one here is 15 sine 60. Or you could have typed in 15 cos 30. Because you can think about it like this. This is also the same here. So you can either say it's cos 30 or sine 60. Depends on the way you look at it. And this is cos 60 or it's either sine 30. Again, depending on how you're looking at it. So what do we get for the east and for the north? 7.5 kilometers per hour east and so 13.0, yeah. Kilometers per hour north. Yeah? We're okay with that? Yeah. Right, let's see. Now, I'll let you try this again first. A plane can fly at 200 kilometers. Oh, look, no H this time. Great. A plane can fly at 200 kilometers per hour in still air. That means if there's no wind, it can fly at 200. Okay? The plane heads northeast. So the plane is heading northeast. Okay? But there's a wind blowing from the west. So there's a wind blowing this way. And this is the plane here. What is the magnitude and direction of the plane's velocity? So what's going to happen is this wind is going to add to the plane and affect its direction and its angle. If there was no wind, it would be 45 degrees finished. But now because there is a wind, this will get changed. The horizontal component, exactly. So I want to know what's the magnitude and direction of the plane's velocity. So in other words, factor in the wind. How does that change things? My hint to you is you should begin by resolving the plane and imagine there's no wind, then add the wind in.
So the angle is 45 degrees.
Initially, but it changes because of the result of the wind. Got it? Okay, how are we doing for this? We getting an answer? Yeah?
280.
280 you're going with the magnitude, and what's the direction? The angle? Yeah. So, let's have a look. First, the plane tries to go 200 at 45 northeast. This is 200 cos 45, and this one here is 200 sine 45, yeah? But then there's a wind of 100. So there's a wind blowing here of 100. So that adds 100 to this side. So the new triangle will look longer. It will look like this. What is this, please? And what is this, please?
242.
Is which one? The bottom?
Yeah.
241.4, and then this side?
141.4.
0.4. Yeah. We want to know the magnitude and the angle. So what is the speed, the magnitude? It'll be square root this squared plus this squared. So what did you get? 280. Yeah. Meters per second? No. Kilometers per hour. Kilometers per hour. And then the angle? Not quite northeast. It'll be less than 45 now. So it'll be tan inverse this over this. What do you get? Yeah. Yeah, it should be less than 45 now.
Shouldn't it be north of east?
Yeah, you could write that as, you could also write 30.4 north of east. It's the same meaning.
So at east of north is the same meaning.
Yeah, these have the same meaning.
Oh, okay.
Yeah. I don't even have to write the word at. That might be confusing. You can just separate it by a comma. Oh, let's be fancy. Let's separate it with a semicolon. There now. Okay. We have that? Yeah. Yeah, just one more example. A bird is trying to fly north. The bird wants to go north, but there's a wind from the northeast. So it's similar. You have a wind from the northeast. So here's the wind. And we have a bird here, and the bird wants to go north. This is where it wants to go. And the wind is pushing down with 200 newtons. Now here's the problem. If the bird flies north, will it travel north? No, because what will happen? The wind will push it off course, won't it? So which way should the bird head? It kind of will need to head a little bit this way, so that when the wind adds to it, it pushes it back. Okay?
The same as with currents.
It's same with currents, yeah, you're trying to cancel out the wind. So my question is, in what direction must the bird head? So what angle must it head at here? Okay, and the bird can fly at 100 newtons of force, we'll say. Okay, maybe we'll do this one together. So what I would do here is, I would first resolve the wind into this direction and this direction. So this is 200 cos 45 and 200 sine 45. So I think that's one. Oh, I think I've made a. What's 200 cos 45? Is it?
It's the same as the last question, 141.4.
Oh, okay. The bird is too weak. I need to make it stronger. We'll make it be able to fly at 300 newtons. That's better. Okay. And the other direction?
141.4.
141.4 newtons. And the bird can fly at 300. Now the bird should not put the 300 in the north. How much should the bird put this way?
300 less 141.
Not quite, no.
Half of it?
No. You should put, the bird should put exactly 141.
Oh,
Why? To cancel that. Then whatever the bird has left,
yeah.
it can use to head north. Now, it will lose some of it. Why will it lose some of this? Because of the wind going down here. But as long as it's more than that, it should be okay. I hope I made it strong enough. We'll see if it can head north. Right, okay. So, the bird ends up heading this way. Well, I mean, it tries to head this way and then the wind pushes it back. We know how big this is. This should be 300. The bird puts its 300 this way so that 141 can go that way and we have a little bit left to go that way. But how can I get this side? Well, I can just say it's 141.4 squared plus y squared equals 300. So what's y, please?
300. Wait, 300.
Oh, 300 squared. Thank you, thank you. I forgot about go. Please give me a number bigger than 140. What you get for y? 100 and
264.
264.56
Oh, yeah,
newtons. Okay, so let's just recap what we're saying here. The wind pushes this way with 141.4 and 141.4. The bird should push this way with 141.4 and this way with 264.6. That gives us its 300. Okay? If you add these together, what will happen? At the end of the day, this and this will cancel, and the bird will get its wish and head north. How much force is directed north? 264.6 minus 141.4. But I don't care about that, because I only wanted to know the angle. I wanted to know this angle, or this angle, whichever. So if I get this angle, it's tan inverse 264.6 over 141.4. So 61.9.
61.9.
Yeah. Is the answer. The bird has to head at this angle. This will cancel the effect of the wind. You were mentioning about currents earlier. You were saying about the current. So, yeah, in the exam it doesn't really matter. Sometimes the question's about wind and sometimes it's about currents in the river or whatever. So it's the same idea. Okay, did you write that down? You have that? My very important attendance sheet. Kai Hong. Yeah.
And the wind is 45 degrees, right?
Yeah. Zach. Son. Lynn. Harry. There you are. Regina. Jeffrey. Dorian. And Diego. Or Diego, isn't it?
Diego,
Yeah. Okay. You got that? what we'll do, just for 5 minutes, I want you to have a look at the questions in the workbook, just for 5 minutes, get a start on them, and then we'll do the next lesson. Can I close this? Yeah. So you can open up Moodle. What's it called? What did I call it? Resolving vectors, was it? Yeah, there we go. So that one has 6 questions. Yeah. Oh, that's strange. It doesn't have the year in this page. I need to go back to the workbook. Yeah, it doesn't this one. I'll fix that later. Resolving vectors. Okay. Right, if you can just... What shapers? Right, if you can just try these for a few minutes on your phone.